Good morning, good afternoon, and good evening. Welcome to another webinar from Continuent. And today we're talking about hybrid and multi-cloud and how we can use this to achieve the ultimate MySQL availability. My name is Matthew Lang. I am a Customer Success Director of the Americas here at Continuent, and I've been using databases for about 25 years. I've used MySQL as well as other open source and closed source databases. So let's get into it. So this is probably a review, but let's just make sure. So why cloud, right? Why should we move our workloads to the cloud? Well, there are some really great advantages, right? So we can deploy just basically point and click and have our workload move to the cloud. We can use command line tools to provision instances and resources, or we can use an API. And using an API that allows us to use various orchestration tools and automation tools. Um, we don't have to maintain any physical servers, right? Our cloud provider does that for us. And then also, we don't need to pay others to maintain physical servers, and we don't need to rent physical servers, aka co-location, right? Um, Everything is managed for us in the cloud. So if a server goes down or there's a networking problem, we may experience application outages, but we don't have to worry about the actual reprovisioning of server instances or fixing network issues or bad cables or anything like that. That's all done for us. It's fairly easy to scale up and down, horizontally and vertically. So we can add more instances to scale up, and we can also resize our instances to make them larger. It's another way of scaling up. And we can scale down too. We can do the opposite. We can remove instances, for instance, remove application servers, or make our database servers a little smaller during times of less usage. And that will allow us to save some money. And of course, the cloud, pay for only what you use, right? So if you're running for 1 hour, you just pay for 1 hour. If you're running for a month and then you want to shut down, you just pay for the month. Now, I've posted this little bonus question in here because trying to figure out how much you're going to pay can be quite difficult. So in AWS, doing a fast snapshot restore on EBS, how much does that cost per minute? It's kind of hard. You can look it up, but it's kind of hard to plan the exact cost. So it's just one thing that you need to be careful with when deploying to the cloud is that you can get a general idea of your costs and estimate it, but there may be some additional unexpected costs. Again, with proper planning, you can be cost effective. One way to do this is instead of paying by the minute or by the hour, you can buy reserved instances or pay upfront for, let's say, a year usage. And you normally get a pretty nice discount when you do that. So if you can commit to a certain period of time, pay for it in advance, you'll get better pricing. And that's just one way of minimizing your prices. So let's look on how we would get into the cloud, right? Let's say we deploy into a single cloud region, right? So each cloud provider has several regions, maybe US East, US West, maybe several in South America. But you pick a region and you deploy your application. So what's good about that? Well, you're getting all the advantages that we just talked about on the previous slide, right? You've got point and click, you can do automations and scale up or scale down your workloads. You don't have any more physical servers to worry about. That's all handled by your cloud provider. And you can pay as you go. If you need the server, say for 2 months, then pay for 2 months. If you need it longer, then you pay for however long you're using it. So if we do this, what kind of challenges could we come into? Well, if you had physical servers and all of a sudden you're not using them, well, what do you do? Maybe they're completely viable, and maybe they're actually quite good, and you have a data center that's planned out, spec'd out, and everything's working. It's kind of a shame to see that go to waste. Um, and second thing is, when you pick a region, that region is probably not close to all of your customers, unless all of your customers are concentrated in one small geographical area. But that's typically not the case. So for instance, if I deploy in US East 1, that's not really going to be the best user experience for my users in California. However, for my users in Virginia, that's quite good. So aside from that, what if there's a regional failure? Or what if there's a failure of one or more availability zones in that region? Well, if the region is down, your app is down and your customers cannot use your application anymore. If you have a couple of AZs down in a region and they happen to be the AZs that you're deployed in, you're also down. So there's a little bit of risk there by deploying only in one region. And then we have no disaster recovery, right? If the region goes down, we're down. We have nowhere to fail over to. So what we would do in this case as well, the obvious thing is to deploy in multiple regions. Um, so now we have disaster recovery. If US East 1 fails, we can fail over to US West 1. This also allows us to distribute our application closer to our users. So now our users in California are going to have a great user experience, as well as our users in Virginia. And deploying in more than one region now opens up some more sophisticated topologies, multi-site, multi-master, and active and passive with failover and failback. So what challenges now do we have with this? Well, there's a little bit more work to deploy an application multi-region. Our application needs to be aware that it's deployed in more than one region. There's some orchestration that has to happen to make sure that we have sufficient app servers and database servers in each region. And we're deployed in the cloud in multiple regions. However, with one particular cloud provider, we're kind of locked in. It's not easy to get out of this cloud provider and get into another one if we wanted to. And we're going to pay whatever the cloud provider charges us. Now, for some larger enterprises, you may be able to negotiate the fees for that particular cloud provider, but at the end of the day, they're the ones setting the pricing. And again, if you had physical servers in your data center and you're not using them anymore, well, that's kind of a waste as well. So, the idea is we don't want to waste resources or pay for something that we're not using. So, but even still, uh, all cloud providers have outages, have had outages, and at some point will have outages. It's just not possible to build something that's going to be 100% always available forever. So we can see actually back in March that Google Cloud had a pretty big disruption. A couple years ago, AWS had a major outage, and it was just due to a mistyped command. But that was down for 4 hours, and just S&P 500 companies suffered $150 million in losses. 4 hours is a long time. And my favorite one, and this is one that I've personally dealt with, that a cascading software bug back in 2012 brought down almost all of Amazon. And what's interesting about that is not only did it bring down the servers and they were inaccessible, but the actual management console was being throttled and you couldn't even connect to it. So you couldn't fail over, you couldn't deploy new servers, right? Because you actually couldn't get to the management piece. Um, and like I said, I experienced that in a previous company where we deployed everything in the cloud. And a few days later, this happened and we were offline completely. And we couldn't even make it to the management console. So what can we do to try to mitigate this for availability? Well, we can do hybrid cloud, right? So what is hybrid cloud? Well, that's where we are going to take our physical data center, our physical servers, and continue to use them, but also deploy in the cloud. So if we look here, we're using our data center still because it works, right? We're fully invested in our data center, and we've estimated that we have years of viability to use this data center. So why let it go to waste? But at the same time, we want to take advantage of all the cloud features. So let's add a second site, and that site is US East 1 in the cloud, for instance. And we can use this site for DR. If our data center, physical data center goes offline, we can fail over to the cloud. Or we can have the cloud be an active site as well. And we can deploy again in several regions in this cloud, as well as our physical data center, and geographically spread out our applications closer to our end users. So that gives our end users the best possible user experience. The closer our application is physically to our users, the faster it's going to perform and the better user experience. And this also is a great stepping stone really to get into the cloud, right? We could have this set up with the idea of eventually we're going to migrate fully to the cloud. What else can we do? Let's say we don't have physical data servers, right? Let's use multi-cloud. What's multi-cloud? Well, multi-cloud is we're going to leverage more than one cloud provider. So in this instance, we can leverage AWS in the east and Google Cloud in the west. And we could say have a third cloud, say in Azure somewhere else. So if we deploy our applications in two or more clouds, now we get the features of each cloud provider, right? We can fail over from one cloud provider to another. So if AWS has a regional failure, no problem. We fail over to Google Cloud and we are now unaffected by the AWS outage and vice versa. It's a great way to move your applications so we can extend our deployment from AWS into Google Cloud with the idea that eventually we're going to migrate to Google Cloud or vice versa. This also is good for enterprise level organizations that do negotiation because we can actually come back to our cloud provider and say, look, we're deployed in this other cloud provider and we're getting this pricing. We want you to do better. So we have some leverage on pricing if we're able to actually negotiate in the first place. So, and again, we can deploy closer to our users. And each cloud provider has a number of regions. Well, by leveraging multiple cloud providers, we get that many more regions to deploy our application. So one thing you may be thinking of is, well, what about managed database services? A managed database service is something like RDS in Amazon for Aurora and MySQL, and also Google Cloud SQL. And the goal there is to make it easy to deploy databases. Again, you just kind of point and click, and you can create a database. They work pretty well, but there are some limitations, and especially when we consider hybrid and multi-cloud. Namely, if a cloud provider has a managed database, it's only going to be available, of course, in that provider. So you're not going to be able to extend RDS to on-prem or in Google Cloud, for instance. And even within the same cloud, it's not really a trivial task to build an HA application to support multiple regions and certainly not multiple clouds. The pieces aren't all there, and they have their own kind of intrinsic idiosyncrasies that makes it harder to fail over or especially fail back. And it's really difficult to do any kind of complex topologies, for instance, multi-site, multi-master, or fan in and fan out with a managed database servers. And one thing that's sometimes people overlook is that, okay, it provides failover, great, but how do you fail back? And is that supported? And oftentimes the fail back is not supported, which requires a little bit more effort to recreate the databases in the DR sites and then eventually promote them back to primary. Of course, vendor lock-in plays in here. If you're deployed using a managed database service, you're locked into that particular cloud provider. They make it really easy to get your data in, but getting it out is much more difficult. So getting it in, it's easy to load. It's typically free. Getting your data out, it's extremely difficult to dump the data and would most likely require some amount of downtime to get a consistent backup to get it out of the cloud. Um, they are quite pricey, and a managed database instance might be just a little bit more than a regular instance running MySQL on it. However, when you start scaling this, now you have to multiply by the number of servers or instances that you have or replicas that you have and pay for that. And that could start getting really pricey when you start deploying, say, 10 replicas. And again, multi-region support, even within the same cloud, is there. It's somewhat limited. Again, failback oftentimes isn't supported. Multi-master between two sites is usually not supported. There's some progress though, and it's getting better. So then, how do we deploy hybrid and multi-cloud applications? Well, we need a few pieces to make this happen. We need the following components. We need replication, right? We have to be able to replicate our databases and keep them in sync between the various clouds and on-prem. Without that, well, we can really only deploy a single database. So we need the ability to switch roles within the cluster too. So if a replica is now going to become the primary, now we are no longer writing to that replica, we are extracting from it. So we are extracting from a new master and writing to a slave. And the replication piece has to be able to adapt to changing roles within the cluster. We also need an intelligent MySQL proxy. What's that going to do? Our applications need to connect to a proxy, and then the proxy connects to the appropriate database server on the back end. So if we have a write from the application, that write by definition has to go to the master. However, maybe we want to read from the slaves. Since they are in sync, we might as well leverage the slaves for read. And that keeps the load off the master. And by spreading the load out, we can really scale up and take advantage of our slaves or secondaries. This proxy needs to know what the state of each database is in the entire topology. So we need to know which database is primary, who's secondary, and where they're located. And then we need another piece to manage all this together, right? So we need a manager to check the health of each node in the cluster and to be able to orchestrate failovers and changing the roles of all components. So the manager must notify the replicator that, hey, we're promoting a slave to a master, and it needs to notify the proxy as well. So we have a complete orchestration of a failover or just a switch. And one other thing that's really important to have is a dashboard or a GUI interface that we can actually look at the entire cluster on one single pane. So if you're deployed in multiple clouds, each cloud provider is going to have its own view of the components deployed within its cluster. However, we're not going to be able to log into one cloud provider and see the components on other cloud providers by definition. So if we deploy, say, in AWS in Google Cloud, AWS is going to show us our AWS cluster, but it's not going to show our Google Cloud cluster and vice versa. So we really need a way to be able to see the whole cluster. And by the way, most cloud providers as well, even if you deploy in multiple regions in the same cloud provider, you can still only look at one region at a time. So we really need a way to be able to look at the entire cluster, no matter where it's deployed. So at Continuent, we've been doing this since 2009, so we have a lot of experience with cloud deployments and clustering and high availability. We provide all the pieces to allow enterprises to deploy geo-distributed MySQL application on-prem, in the cloud, hybrid cloud, or multi-cloud environments. We also enable continuous operations and business-critical MySQL applications to run at scale with zero downtime, right? Because we provide all the HA and all the failover necessary for that. And each employee at Continuent has a minimum of 20 years of database experience, and we use that to provide excellent support. And this is why we are called the MySQL Availability Company. So let's look at how we do this. So at the core, we provide Tungsten clustering. And this provides all the pieces that we need to deploy a local HA cluster. We have the replication, Tungsten replicator. We have a manager, and we have the intelligent MySQL proxy that we call the connector. So when we deploy in a single region, this is a cluster that supports continuous MySQL operations. We can do zero downtime maintenance. We've got replication happening within the cluster, and replication changes roles as the database nodes change roles. And we support MySQL any version, as well as MariaDB, as well as Percona, and you can mix and max versions as you wish. You're not tied to a single version. So if we extend this, we can deploy multiple MySQL clusters, and we can deploy multiple clusters, some in the cloud, some on-prem, and on different clouds. We support on-prem and any cloud. And one of the topologies that we offer is what we call a primary DR Geo-Cluster, right? So we have one cluster that's considered the primary cluster because it has a master or primary MySQL node that accepts writes for the whole cluster. And then we deploy secondary or DR clusters in other sites or other regions on any cloud provider, right? And what this does is it allows a cluster and application servers to be deployed close to our users. And we could pick the regions that we want to deploy in so that we give the users the best user experience possible. If we have a regional outage, we can fail over the master cluster to one of the secondary clusters and promote it to master. And this can happen on another cloud. So we can fail over from, let's say, Amazon to Google Cloud, or fail over to on-site. When our region that went down comes back up, we can fail back to that region. We do not have to redeploy databases to fail back. Again, powering this is Tungsten Replicator that keeps all the databases in sync, and then the Tungsten connector writes to the single master in the cluster, and it can optionally read from its local slaves. So that's how we give users this great user experience, by reading from its local slaves. Let's look also at multi-master, right? We can deploy a number of clusters all connected together by replication, all in sync, and each one having a master. So in essence, we have a mesh of active writable clusters. So we can deploy, again, some of these clusters on-prem, some in one cloud, some in another. We can mix and match however we would like to do it. All clusters support read operations and write operations. So now we can deploy read and write close to our users. We can do this across the globe, and the clusters remain in sync. If a particular cloud provider goes down and we are deployed in a second cloud provider, no problem. That second cloud provider still remains up. The cluster is still active. And when the first provider comes back online, we can resync up and bring those clusters back online. And then we talked about the management piece or the dashboard. And we also provide that too. So what you can see is the Tungsten dashboard, which has a complete picture of all the clusters and all the components in each cluster on a single pane. So this makes it extremely easy to manage all of your clusters and components. And we can quickly look and see if there are any health issues with any of our clusters at all and address them. And in addition to having a nice GUI interface, we also have a command line interface as well for those that prefer to use the command line and do simple scripting or orchestration like that. So let's go over in more detail about the key benefits that tungsten clustering offers. Continuous MySQL operations, right? Uh, Even being offline for a minute can be catastrophic for some businesses. So that's why we provide high availability. We can fail over in seconds if there's an issue with the primary MySQL database in a cluster. That also provides redundancy by having multiple slaves, and we can add slaves to scale out and read from more nodes. So even if we have a failed master and we provision a slave to become master, we can bring that old master back online when the underlying instance is repaired and just have it catch up with replication. And we provide the Tungsten dashboard, which gives a graphical management tool to manage all of your clusters on one single pane. We can fail over cross-site as well. If a particular cloud goes down, a particular region, we can fail over to another cloud or another region. We can do local maintenance as well. For instance, we want to resize our instances. Well, we can do that without incurring downtime. And then we are fully MySQL compatible. We are a bolt-on application. You do not need to change your applications, and you do not need to change your MySQL installation. We simply sit on top of MySQL in your applications. And as we saw, we provide topologies for the geoscale, right? We can deploy across multiple regions, multiple clouds, and we can load balance MySQL operations locally across slaves, and we can easily add MySQL clusters as needed for additional user performance and for additional scaling, whether it's local or in another region across the globe. And as we saw, of course, we support hybrid and multiple cloud MySQL. So if you still want to use your physical data servers, but deploy in the cloud as well, we can deploy in both of those and keep your clusters in sync, and we can fail over from one to the other. If we have a regional outage or a cloud provider has an outage, we can fail over to another cluster in another region that's completely up to date. And one of the important things that we provide is an intelligent MySQL proxy. So as we saw, the applications connect to the proxy, and the proxy decides where the read or write traffic should go. So the read traffic could go to any local slave, and the write traffic will go to either a local master, or if we have a single master in our topology, it will route it to that master. And this is really intelligent read-write scaling. So we can do SQL inspection to determine is this a read or a write and route it that way. And then one of the key things as well is during a failover, your application servers do not get disconnected from the connector, which means your applications don't get an error and your users don't see an error message. They don't even notice that there is a failover that just happened in your backend. And then, of course, MySQL replication. So Tungsten Replicator handles all of the replication asynchronously between the remote clusters and locally between the MySQL servers. It has some other uses too outside of this. Uh, we won't go into detail in this webinar, but we'd be happy to discuss it with you. But Tungsten Replicator can replicate from MySQL to a bunch of other targets. Hadoop, ClickHouse, Redshift and AWS, Kafka, Vertica. And what's kind of cool about this is you don't need ETL anymore. You can do real-time replication, and you can combine distinct MySQL servers or clusters and have them fan into a single data warehouse. Again, we are a bolt-on application. This means we fully support any version of MySQL. You don't have to change your application. We support SSL for all traffic. So whether it's replication traffic, our internal management traffic, or your application to the connector and connector to the database, you're fully SSL if you wish to be, fully encrypted. And again, we're MySQL compatible. We don't change anything in MySQL, so your application is already compatible and there's no need to change. So again, talk about cost savings. Use off-the-shelf MySQL open source, not a problem. You can scale up or scale out. You can scale out by adding additional nodes to read and write from. Downtime. So that's something that can be extremely expensive to a company, and we eliminate that. Our failover happens extremely quickly, and again, the users wouldn't even notice. And DBAs are free now to do other things rather than to write a complete solution to handle failover and high availability. We've already done that, and we've been doing it for over 10 years. Our product is extremely mature. Therefore, your DBA can get back to doing stuff that DBA should be doing, like performance or anything else, but they don't have to worry about high availability because it's already built in. And one of the things that we are particularly proud of is our customer service and support. So each one of us has had a minimum of 15 years of MySQL database experience, as well as site reliability experience. So we've been on the front lines and in the trenches. We know how important high availability is, and we've worked on this stuff for all of our careers. The 24/7 support comes included with our clustering software subscription and has a 1 hour SLA, but response times for urgent cases, for instance, when a system is down or you're having major issues, average less than 5 minutes, and we're quite proud of that. And in general, uh, our customers' MySQL uptime is measured in months or even years because our software is made to keep MySQL online and to keep it available. So we'd love to hear from you. We'd love to hear your feedback or any questions that you may have. Feel free to contact any one of us here or just go on the site and have a look around. And there's a contact form. Feel free to ask us whatever you'd like or connect with us. And we look forward to hearing from you. Again, my name is Matthew Lang. And until next time, thank you and goodbye.